Hello and welcome to the Test Execution and Defect Management course. In this course, you will be provided with some actual hands-on experience with how to test a live application and also how to create and file a system defect, as well as some other valuable information. Before we move forward into the course, allow me to introduce myself. My name is Allison Woodley Tahimba. I am the owner and the CEO of Thornton's Consulting Firm. I have over 18 years of experience in the software development field. I have over 3 industry certifications. I am a certified tester, a certified Scrum Master, and I also have a certification in ITIL. I have managed and led the testing efforts for hundreds of software development projects. Let's review the course topics. They are system requirements and user stories, test cases and test scenarios, system defects, how to manually execute a test case, how to create a defect, test execution status report, your career as a software tester, and we will end the course with resources. Hello and welcome to Module 1. In this module, I will discuss system requirements and user stories and how software testers utilize these documents. So what are system requirements? Well, system requirements are also known as system requirement specification. It is a document that provides a description of a software that is to be developed or enhanced. It established the basis for an agreement between the customers and the contractors or the suppliers. It lays out and details the functionality, the non-functionality that is required for the customers as well as its users. It also defines at a high level the main business processes that are to be supported. So who writes these system requirements? Well, in many cases, there might be a business analyst that might create the system requirements. In some organizations, there might be a project manager or a product owner, or maybe some other member of the project team. But again, in most cases, it is a business analyst that creates the system requirements. So who uses these requirements? Well, every member on the team will read the system requirements. However, the software tester and the developer really analyze and review these requirements in order to perform their jobs. So for example, a software tester will read and analyze the system requirements to aid them in creating test scenarios and test cases, which we will see later in the course. Here I have an example of a system requirement. So in this requirements, it is the login functionality requirement. And it details exactly how the login feature should function. So when a customer puts in, or when a user puts in their login name and their password, here in the requirements, it details exactly how the system should function. So for example, in requirement 1.1.1, on a successful member login on the home page, it should be available with the welcome message. It said welcome to Cyclo's version with the version number. And requirements 1.1.2, when the wrong user ID and or password is provided, the user should receive an error message. And the message should state, invalid login, please try again. In requirements 1.1.3, when the user ID and or the password field is not provided, the user should receive an error message that states login name is required and the password name is required. Also in this example, we have some attributes for each field. So take, for example, the login name field. It states in this requirement that the minimum value that should be entered for this field, it's 4. The maximum value is 16. It is a mandatory field. And it also states that this field should only accept alpha and numeric characters. Let's move forward with the password field. Similar to the login field, the minimum field value is 4. However, the maximum field value is 25. It is also a mandatory field, and it accepts alpha and numeric characters. Now that we've completed system requirements, let's take a look at user stories. User stories are a short, simple description of a feature told from the perspective of the person who desires the new capabilities, usually a customer or users of the system. It describes the type of users and what they want and why. So who writes the user stories? Well, any member on the project team can write a user story. A software tester and a developer, much like the system requirements, a software tester will analyze the user stories to help them generate test scenarios and write test cases. Here's an example of a user story. And as you can see here, it is quite different than the system requirements. As I stated earlier, there's a very short, brief description of the user stories. So let's review this sample here. The short narrative states that it's a pin orders to a home page. So as a customer of the Buy Too Much website, I want to be able to pin orders on my customer's home screen so that I can track the status of the orders that I have placed. You can see here on the back of the user stories, there is a few acceptance criteria. And this is an example of a manual user story. So in the case if a company is creating user stories on an index card versus a tool, they would have this information as it appears here in this example. And again, on the back, you would have acceptance criteria as well as some failures. And the test analyst or the tester would take this user story to assist them with coming up with test scenarios and test cases, as I mentioned earlier. Hello and welcome to Module 2. In this module, I will discuss test cases and test scenarios and how to create them both. So what is a test case? Well, a test case is a set of test inputs, execution conditions, and expected results developed for a particular objective, such as to exercise a particular program path or to verify compliance with a specific requirement. The language. A test case should be very simple and easy to understand. Someone with little or no knowledge of that system or the functionality should be able to understand a test case. So what are the characteristics of a good test case? It should be very simple, as I mentioned. It should be traceable to a particular requirement. A test case should be repeatable and reusable. It should also have a unique name assigned to it. There are different types of test cases. Here I've listed just a couple. You have a functionality test case, A functionality test case is used to discover if an application interface works with the rest of the system and its users. Generally, the author of a functionality test case is a software tester. Then you have the user interface test case. And these test cases are used to verify the specific piece of the graphical user interface, that is the GUI, and how it looks and how it should perform. So take, for example, you have a text box on an application, and that text box, the requirement states that it should accept only alpha characters. Well, tester would test that form out of that field out to make sure that that field accepts only alpha characters. And here's just some more information on a GUI test case. They can be used to identify cosmetics, inconsistency, grammar, and spelling errors, links, and other elements that the user interacts with or sees. And they are also generally written by the software testing team. However, sometimes there might be a design team that will create a user interface or a GUI test case. And here's just an example of a test case. Let's review just some of the fields. The system that will be tested here in this test case, they're testing an ATM system. They also have the subsystem that they're testing. They're testing the PIN functionality. They have a short description here. They're testing the ATM change PIN service. We have some preconditions. So before this test case is executed, there are some things that must take place prior to executing this test case. So here's just 3 of them that are listed. The user has a valid ATM card. The user has accessed the ATM by placing his ATM card in the machine. The current PIN is 1234, and the system displays the main menu. So again, these are some preconditions. Here are the steps, as well as the actions that should be performed, what the expected results are. So after a user or a tester enters clicks the change PIN button, the system should display a message asking the user to enter the PIN. If anything else outside of this happens, this test case will fail. There's also a pass and fail column, as well as a comment column. So let's discuss test scenarios and what they are. Test scenarios is a functionality that can be tested. It is also called a test condition or a test idea. As a tester, you may put yourself into the end user's shoes and figure out the real-world scenario and use case of the application that's under test. So say, for example, you're testing the ATM PIN functionality, and the system requirement states that the ATM PIN accepts 4 numeric characters. As a tester, you want to come up with several ideas on how to test that ATM PIN functionality. The requirement stated that it accepts only 4 numeric characters. So, one of the tests you can conduct is testing the system to ensure that it accepts only 4 numeric characters. You can also come up with another test. Another test would be to try to test the ATM PIN with more than 4 numeric characters. And another scenario or another test idea would be is to test the system to see if it would accept 3 numeric characters. And again, these are just some examples of test scenarios and test ideas to test out a ATM functionality.
Here, as you can see on your screen here, is a copy of a system requirement specification for an application that is called Cyclos. In this demonstration, you will see exactly what a software tester does. The software tester read and analyze requirements. They then generate test scenarios and test cases. On the right-hand side of the screen is actually an example of some test scenarios that I will review later on. So let's move forward reviewing the Cyclos system specifications. So what I'm doing right now, I'm going to just scroll down to the functionality that we will be testing, and that is the login functionality requirement. That is requirement number 1. So let's scroll down to that requirement. And here's just some information about the Cyclos website. And I'm just moving forward. To access the website, here is the URL, and I'll just make a copy of it because we will log on to it later on. And let me scroll down. So here, requirement number 1 is the login functionality requirement. Here's a screenshot of the landing page or the home page of the Cyclos application. And for this exercise, we will write test scenarios and test cases for these requirements below. Requirements 1.1.1, .2, and .3. So let's review. In requirement 1.1.1 for this system login page, when a user logs in successfully, they should receive a message stating, "Welcome to Cyclos version And then requirement number 2, when a user enters an invalid error message, when a user enters the wrong login name or password, they will receive a message stating the given login name or password is incorrect. Please try again. In .3, the user will receive another message when the login name or the password fields are left blank. The message that they will receive is the action could be processed as there was a validation error. Login name is required or the password is required. Here's just some more additional information about just some of the fields, the mandatory fields for that login, those login fields. So you have the login name and the password here. These both are mandatory fields. The minimum data field value that's required for the login name field is 4. The maximum amount is 16. And that field should only accept alpha and numeric characters. The password field, the minimum value accepted is 4. The maximum is 25. And this is also a mandatory field. So I'm going to move the screen over here just a little bit more. And as you can see, the requirements, there's some more information about this new user registration functionality. The name, the login name, the email address, these are all mandatory fields. These are some additional fields that are on that new user, for the new user registration. It is mandatory that this checkbox, I agree with the above registration agreement. That box must be checked along with this visual validation information. That information must be entered in this new code field before clicking submit. And here's some additional information about the new user registration functionality. The tester would read this information as well to assist them in writing their test scenarios. So I'm going to scroll down here a little more, and here are some more information about the other fields associated with the new user registration. The mobile phone field, no information is required. This is not a mandatory field, as you can see. And as I mentioned, these are some additional information about that new user registration. So let's move over to this decision table. And the decision table is a technique that a tester could use to aid them in creating test scenarios and coming up with test ideas. And as you learned earlier in the system requirements, the name, the login name and email address, as well as the password, the confirm password, I agree with the above registration checkbox, and the new code text box. These are all mandatory fields. So in the decision table, what a tester would do is create this table, list all of these field names. And in the scenario 1 here, Y means yes. Yes, the valid value is entered into that field. And the login, the same thing, as well as the email address. So, and once the user clicked the submit button, they should receive two things. They should receive the message stating that, thank you for registering. We're going to put yes right here. And then they should also receive a validation message in their email informing them for some additional steps or additional things that they should do before they log in. Next, we are going to test the second scenario. And if I can go back over here to the system requirements and requirements 1.1.2, we're going to create a scenario for this one. And in that one, when a wrong name or password is provided, they should receive an error message. So we're going to test that feature out as well. And so here we put in a valid name, and in the login name, we're going to put in the wrong name in the login name field. The email address is correct. Now what should happen here, the user should not receive thank you for registering because they put in invalid information into that login name field as the system requirement stated. And then here in the email address field, they're not going to receive an email, because they put in incorrect information. However, they will receive a message informing them that that login name and that password is incorrect. Please try. So here the answer should be yes, or yes should appear in this box. Next, we're going to test the .3 functionality. And in this one, it states that when those fields are left blank, another message should appear. So here in test scenario 3, this time we're going to leave that field blank, the login name field. And instead of receiving this error message that the information is incorrect, the user should receive, or the tester should receive, another message. And that message should state the action could not be proceeded as there was the validation error. The login name and or the password is required. And here we're going to answer yes. So after the tester has created all of their scenarios, they're going to convert those scenarios into test cases. Now, as you can see here, there are some additional scenarios that a tester could create to test this functionality out. They could come up with some other scenarios where the email address is left blank. But for time, we're just going to test these 3 requirements here. So let's move on to the test case. And the test case name is new user registration. The system is Cyclos, and the subsystem is the new user registration. So the name of the test case is new user registration, and the system we're testing is the Cyclos new user registration. So what is the purpose of this test? Well, the purpose of this test is to test the login functionality to ensure that it's functioning as designed. You could put something similar to this, or you can put that you're testing to make sure that the new user functionality function as designed. You also want to put the author's name, and in this example, I put my name, the date the test case was created, and any preconditions, anything that the tester should do before they can execute these steps. That information should go on the test case. And in this case, we have just one. And basically, the user must be, the tester should be on the Cyclos homepage or the landing page before they can execute step 1. Now let's go to the actual test case. This test case right here, this is the first test. And if you recall, we created 3 scenarios. So this test ID and this one represents the first test. Then we have a step 1. And if you recall, in the definition of test cases, we stated that a test case, the language should be very simple. So which means anyone with little or no knowledge of the Cyclos application, this person should be able to pick this test case up and execute these steps. And so let's review the action, the first step. Click on the register link located in the upper right hand corner of the Cyclos homepage. This is just a step. The expected results. So after that user clicks that link, the expected results states that the new user registration page should appear. Appears, not should, appears. The second step, that you should enter some information, and in this case, we're entering test green into the name text box. What should happen after you enter that? Test green appears in the name text box. So basically, you have an action, and then in the expected results, you're then listing what should happen after that action. And I'll just scroll on down a little bit further here. And in the final step, after they've entered all of the mandatory information and click the submit button, let's go to step number 9. They click the submit button. That thank you message should appear. Then next, the tester would log into their email account. They've logged in successfully, and they should have the email address, an email from Cyclos. They log in and take steps from there. Here is the second test case that we created, a test scenario. And in this test, if you recall, we're going to put some invalid data into their login name field. Now, the login, based upon the system requirement, it states that the login name, the minimum value is 4. But as you can see here, we have 3. And what should happen when they click submit? That error message should appear. And that final test case, we did the same thing. But in step 3, instead of putting invalid test data, we left out that field blank. And the message that appeared stated that the action couldn't proceed because there was validation error, login name and or password is required.
Hello and welcome to Module 3. In this module, I will discuss system defects. So what are defects? Software defects, or sometimes called bugs, occurs when one of the following occurs. When software doesn't do something the product requirement specification states that it should. It is also when software does something that the product requirement specification doesn't mention. It is also when software doesn't do something that the product requirement specification doesn't mention, but it should. And then finally, a defect is also when the software is difficult to understand, it is hard to use, or is slow to perform. And here I have an example of a software defect. What I would like for you to do is just take a couple of minutes here and examine both pictures. The image on the left is what the client expected. The client provided the development company with a picture on how their logo should appear. The image here on the right was what was delivered to the client. So take a few moments here and study both image and document just some of the differences, at least maybe 5. And I'll give you one for example. The bandana or the scarf that's tied around each person's head. They're different colors. So again, take about 5 minutes and just document at least 5 things that you see that are wrong, that's wrong with the differences between both images. A software failure terms. Depending on the organization that you work for, there are numerous terms. So here we'll just review a few. The most commonly used is defect. You might hear the term bug, fault, incident, variance, failure, or failures. Software defects can have a major impact on the performance of the software. It can also result in death. It can cost millions of dollars to repair if not found at the very early stages in the software development life cycle. And it can also cause mechanical failures. Here's just a few examples of the results of a software defect. In April 1994, the China Airline Flight 140 crashed and it killed 264 crew members and passengers. And this was due to a software bug or defect that wasn't found. Another example of the results of a software defect. Back in May 1996, a major U.S. bank credited 823 customers' accounts with over $920 million. And again, this is a result of a software defect. So why do defects occur? Well, they occur for a number of reasons. But the number one reason as to why defects occur is because of software requirements. Usually there's not enough information. Oftentimes they are incorrect and they change often. The second reason why defects occur within an application is because of designs. Bugs occur here for the same reasons they occur in requirements. The designs are rushed, they change often, and they're not well communicated. The third reason why defects occur is because of coding errors. Unfortunately, developers are humans and they make mistakes. When pressure is put upon them, unfortunately, again, it results in coding problems. when requirements changes or when requirements aren't well communicated with the developer, it can result in coding errors. And then there are other reasons why defects occurs within applications. Sometimes they're not really defects. They're duplicate bugs, there are multiple ones, etc. Let's review the cause of software defects. The cost to fix a bug during the early stages of the software development lifecycle is very inexpensive. So take, for example, during the requirement gathering phase. If a defect is found within the requirement, the cost to fix that defect is roughly around $10. However, if that same defect is found during coding or during the testing stage, that same defect can cost anywhere from $100 to $1,000 or maybe even more to fix it. If that defect is found by a customer, it can cost $10,000 or more to repair. So the lesson here is, again, to find defects very early on in the software development lifecycle. The cheaper it is to repair it. A defect goes through a life cycle. And the life cycle basically is the journey of a defect cycle, which a defect goes through during this lifetime. Now, this will vary from organizations to organizations. There are a number of states that a defect goes through. And again, it varies from organizations to organizations. It can also go from project to project. And here is just an example of a defect life cycle diagram. Stage 1 is new. And all defects are in this stage. This is when a tester would find a defect and create it. And then from there, that same defect goes into assigned. From there, it goes into open, fix, retest, and close. That same defect can go into a deferred status or rejected or duplicate, or it can be reopened. So let's discuss just some of them and what they actually mean. So what does it mean by an assigned defect? Well, an assigned defect is once the bug is posted by the tester, generally the test lead will approve this bug and assign the bug or the defect to the development team. The development team will then change the status from assigned to open. And this is basically the developers starting to analyze and work on the defect to fix it. Well, once the developer has fixed the defect, that person or that developer will change the status to fix. And from there, it will go to retest. The developer will change it to retest, and the software testing team or the tester will actually retest this defect. Now, if the fix, after the test team has retested the fix to make sure that it was fixed and the functionality is now working as designed, that test lead will change the status to close. We have some other phases here, and they are, let's just take a look at a couple of them. If something is reopened, well, a bug is reopened. So take, for example, the test lead has closed the defect. Well, a new release comes out, and that same defect that was found in a previous release or a previous release now is resurfaced. So instead of opening up another defect, a tester would just reopen that same defect. And what does it mean by deferred? Well, in deferred, it is the present bug that is really not a priority. So if a tester finds a defect and the development team, for some reason, they've decided, or the project team has decided that that defect will not be fixed before it is released into that version is released into production, it will be fixed in a later version. Instead of closing it, it will be put in a deferred status, and that is for the defects to be fixed at a later in a later version. Rejected. This happens sometimes. The developer feels that the defect is not genuine, it's not an actual defect, so they will reject it. And the final one we will review is a duplicate. And this is basically self-explanatory. This is just a duplicate defect. Tester A reported the same defect as tester B. So a development team will mark it as duplicate. Defects, when they are created, they must be classified, and there are two classifications. One is the severity, and the other one is priority. So let's review what a severity defect is, or what exactly does it mean by severity. Well, severity is the extent in which the defect can affect the software. And here are just a few. And again, this will change depending on the organization that one is working for. So these are just examples. So some of the severities are as follow. Critical, the defect that results in the termination of the system. So when the system crashes, this would be marked as a severity. Major, the defect that terminates a major function of the system. So take, for example, you've gone to a e-commerce website and you're able to order an item, but unfortunately you're not able to pay for that item with a credit card. You can select it, but once you get to checkout, you're unable to put your credit card in, or you're receiving an error message when trying to submit your credit card. The system is functioning. You're able to log in, things of that nature, and select an item to purchase, but you're unable to check out. This is a major problem. And so that would be an example of a major. And you have your moderate defect. And in the moderate defects, the defect that does not result in a termination, but the causes the system to produce something incorrectly. Again, using the example with the credit card, you're able to process that credit card, but you receive an error message or something after that credit card has been submitted. And then you have minor and cosmetic defects. These type of defects, they generally don't impact the functionality of the system. It could be something cosmetic, and it's not major. These are minor things that might be deferred at a later time, but it impacts the way the application may be looked. There might be something grammatical. And we have a second classification, as I mentioned earlier, is a priority. All defects must be ranked by their priority. And the priority in which we should resolve a defect. So this helps a developer determine which defects should be fixed first. So take, for example, if you have two defects with the same classification, with the same severity, but the priority is different. The defect with the highest priority would be worked on first. So here's just some examples of 3. And you have high, medium, and low. High, the defect must be resolved as soon as possible because the defect is affecting the application or the product severity. The system cannot be used until the repair has been done. So you have a system that is crashing, or you're unable to log into a particular application. The severity would be critical and the priority would be high. So why are some defects are not fixed? Well, sometimes it's just not enough time. And in this case, that defect would be put into a deferred status. Now, generally, the project team, the project managers, and the business owners will have the final say so on which defects that will be deferred. It's not a one person's decision. Generally, it's a group decision led by the business. The development team may also have some input on why the defect will not be fixed. Those defects are not fixed. Another reason is it's too risky to fix it. It's not worth it. And sometimes it is really not a bug. It could be a training issue by the testing team where they've created a defect and it really isn't a bug. And in order to open a defect, you can, depending on the organization, they might be using an Excel spreadsheet. But in today's time, most companies are now using various defect tracking tools to create and open a defect. So here's just a screenshot, an example of a defect tracking tool. And here are just some of the major components. You have a summary. So the tester would put a brief summary of the defect. The type, again, is the defect. And here you can see on the right hand side in red, you have the severity. You also have the detected by, so the tester would put their name. Here you would also have a description. In the description column, the tester would put a detailed description on what happened. They would also put the actual steps that they were executing at the time when the defect occurred. You also would have the ability to attach any screenshots. So say, for example, an error message appeared. You would take a screenshot of that and attach it to this defect report. And if you see here in the lower right hand corner, there's the priority and the status. Right now, the status is marked as no. Hello and welcome to Module 4. In this module, you will have an opportunity to practice. You will see a couple of live demonstrations on what we've learned so far.
In this demonstration, you would get an opportunity to see exactly how a software tester execute a manual test case. So the test cases here on the left were the test cases that we created earlier. So now we are going to test the Cyclo's new user login registration. And so what a tester would do is actually take the manual test case that was created here with Excel, and they would just go through each step and execute the steps. They would enter the information in as they see it here on the test case. So right here on the right, I am following the steps and entering the data from the test case and to these fields here in the Cyclos application. If you're working for a company, and some companies have automated tools that you can use to create test cases, but here we have this manual test case that was created in Excel, and so just scrolling through and following the steps. And we go down a little bit further, and we're almost done with this test case right here. We're just, again, entering in all of the required information. We are checking the appropriate boxes based upon the steps in the test case. And in a second here, we will click the submit button. And thank you for registering, which is what the test case stated that it should do. And we will move on to the second step, the next step, where we would actually log in to our email address and make sure that that validation email appears, which it does here in this example. So we're on this step right here. And we click on this link, and the user is taken to the Cyclos login screen, and it states that the account has been activated. And we'll see one more step here. And now that person, the tester, would sign in using that new user login name and password. So they will put in that login name that they created. And so in this case, it was Nocella2017 along with that password, and sign in. So that's basically what a tester does. They take their test cases, they create it after reviewing the requirements, and here they would go back, and each step that passed or failed, you could do it after each step, or you can, after everything is done, you can go back and just put P or spell out the word pass for each step that passed, which is what I'm doing here in this case. All of those steps pass, so that particular scenario, it passed. We have the other test case here where we can execute those tests, execute those steps here. So it's the same thing as I mentioned earlier. A software tester, they create test scenarios and test cases after reviewing the test cases. After the test cases have been completed, they take that test case and then execute it and test that new system out. Any issues that are found during that time, they create a defect and report those problems to their lead. Their lead then will assign that defect over to the development team to fix it later. So that concludes test execution. Thank you so much. In this demonstration, you would have an opportunity to see how to create a defect using a defect tracking tool. So here, what I'm doing is just logging in, and a test manager or test lead would create a test project for that particular application. So if you recall, the name of the application that we're working on is Cyclos. So what I'm doing here is creating a new project in this defect tracking tool. It's a demo here called Redmine Demo. And so if you like, you can access it yourself just by going to demo.redmine.org and just play around with it. So again, here I am just creating a project, the Cyclos demo project. So I've put in the Cyclos demo name along with a brief description of the project itself. The modules are already pre-selected, so I will keep them. And the trackers, we're tracking bugs, features, and support. And so I'll just hit create and continue. And so my project was successfully created. So now we're set up and we're ready to create defects. So I am going to actually go back here and find the project. So we have Cyclos Demo. That's the name of the project. As you can see here, my name is there, Allison Whitley Hemble. I am the manager. I'm going to click on the New Issue tab, and we're going to pretend that we found a defect during our test execution, just so you can see an example of how to create a defect. So the subject line, we'll just write a brief description on the error message. So I put error message did not appear, or something of that nature. Error message was incorrect. So again, just a brief description of the error message you receive. In the description text box below, you have a lot more landscape to enter additional information. So here I'm going to just add some more information about the error message that I received. And another thing too, and you will see this in a second, a tester will also enter the steps to reproduce the error message. This is very important, to put the steps to reproduce the error message. So when a tester is reporting these issues to a developer will know exactly where, at what point that error message occurred. So this assists them greatly with their troubleshooting and debugging when they're trying to fix the problem. So in a second, you'll get a chance to see just some of what I just spoke about, putting the steps to reproduce. So the more information you provide in the defect tracking tool, it just assists the developer greatly in finding the root cause of the problem. So here is step to reproduce. And also, if you are using you can also maybe copy the steps from the actual test case into this field. Sometimes it's quicker and easier to just copy the steps instead of typing everything yourself. But we just take a few more seconds here so you can see exactly what happened or what I did, and that was just entering all of the steps. And as I'm doing that, as I'm writing the steps here, let's go over just some of the fields that you learned earlier about the components of a defect. We see the status, the priorities, which we discussed earlier, assignee, who you're assigning this defect to. Also, we have, you'll have an opportunity to insert a screenshot if necessary. So just a few seconds longer, we have the start date, the estimated time. Sometime a developer will put in the estimated time they think it will take to fix the problem. So again, the more information you provide to a developer, the easier it makes their job easier. And so here, what you saw a second is that I went over to the test case itself and copied some information from there. So just a few more seconds here of entering the steps to reproduce. And again, as I mentioned earlier, it's a lot easier to just copy the steps. But this is basically how you create a defect. Should take a few more seconds here once we're done. And I'm scrolling down over here to copy some information from the test case and put that information into the in the defect itself. And the developer will, as I mentioned earlier, that person will look at these steps, execute these steps, and see if they're able to reproduce the problem. And they can go behind the scenes and go to the code and see exactly what's wrong and why there's a problem. So again, it's vital to put as much information as possible in these defect tracking reports. Should be done in a second. And so the problem is the incorrect error message appeared. So that was the problem. So it was an error handling issue. And you scroll down here. And so what I'm doing here is attaching an actual screenshot of the error message. So not only do I have my steps to reproduce, I have proof that this problem did occur. So the developer has everything that they need. And so I'm going to change the priority. So this is urgent. I need to have this problem fixed right away because it's preventing me from moving forward or from this test case passing. And so what it did was create a defect number. And so since that test case failed, I will go to the test case, and at that step where it actually failed, I will put fail and put that defect number. And so when someone else is trying to, or when someone else have to execute this test case, they will see that at that step, it failed. In that test case itself failed. And we have a defect number. So that concludes how to create a defect using a defect tracking tool.
Hello and welcome to Module 5. In this module, we will discuss test execution status reports. So what is a test execution status report? Well, it is a communication that is sent out daily or sometimes weekly with detailed information about the QA team activities during the testing cycle. It includes the test case's execution status, whether a test case passed, failed, blocked, and any defect information as far as the defect number. So who usually gets this information? Who receives this report? Well, a QA lead generally will email this report to the project manager as well as senior management staff, and also certain members of the project team will receive a copy of this report. Here's an example of a test execution status report. Let's review just some of the components. On the left, you will see the total number of test cases that were executed. So here in this example, there were 10 test cases that were executed. 8 of those test cases passed, 2 failed. You would also have information about any test cases that were deferred or blocked, test cases that were not started. If you move to the center of this report, you see information for key issues as well as highlight. So key issues would be a test lead would put some information there. For example, if the testers were unable to test for a couple of hours because of a defect, this information would go here. A little additional information about this report. As I mentioned earlier, you have your project managers and your senior management staff usually are the groups of people that would receive this report. They are, in most cases, they're extremely busy and they just don't have time to read through a lot of detailed information. So on the test execution status report, you want to make sure the key information about the testing activity is front and center for the target audience. So if testers were down for a few hours because of a problem, you would want to make sure that that information is documented here in the key issues section. Any highlights? Well, if there was something positive that happened during testing, you would indicate that information here. Below in the defect log, any test cases that were blocked while testing, you would indicate that test case name and any information about that test case that was blocked. And any test case that failed because of a defect, you will list the test case name as well as the defect number on this report. And over in the right hand section of the report is also a graph of the information that was entered here on the left side. So again, this is just an example. This information could possibly read differently just depending on the organization that one is working for. Hello and welcome to Module 6. In this module, we will discuss your career as a software tester. The field of software testing looks very promising. According to the Bureau of Labor Statistics, there's projected to be a 9% growth from 2016 to 2026. The average income of a software tester is $50,000 annually in major cities like Atlanta, New York, Los Angeles. There's also a tremendous amount of opportunities for growth. You could transition from a entry-level tester to a senior-level tester or a test lead or a test manager. And the more knowledgeable you are on different testing tools, you could become a test automation engineer. Or if you're interested in being into senior management, there's opportunities to become an IT director or a business analyst, a product owner, a scrum master, or even have your own consulting business like myself. And here are just some resources available for freelancing jobs. There's Upwork, there's crowdsourcing and testing. If you're looking for jobs, you can check out Indeed, LinkedIn, Monster. There are also gaming jobs that's available as well through Job Monkey and Glassdoor. And if you need a little bit more hands-on experience, you can check out the Association for Software-Tester.org. And here are just some other additional resources available. There are organizations that are available to network with other software tester professionals or to learn more about the industry. You have the Association for Software Tester, as well as the Software Tester QA Test and the AQAA. If for more information, you can join forums like Sticky Mind or ThoughtWorks or Satisfies, I'm sorry. These are again just some great organizations and resources available for one. And also, if you're interested in becoming a certified tester, here are some great organizations. We have reached the end of the test execution and defect management course. Let's review. In Module 1, we discussed system requirements and user stories. In Module 2, we discussed test cases and test scenarios. In Module 3, we discussed defect management. In Module 4, you had an opportunity to see how to execute a test case in a live demo application. You also had an opportunity to see how to open a defect in the defect tracking tool. In Module 5, we discussed the test status reports, the importance of these reports. And then finally, in Module 6, we discussed your career as a software tester. You were also provided with some great resources. Thank you once again for taking this course. I hope this course has increased your knowledge on the duties and the responsibilities of a software tester. Thank you. Thank you again for your time. I hope you enjoyed the course and you learned some valuable information that will help you in your software testing career. I can be reached by phone or by email, or you can find me through on Facebook at Thornton's Consulting Firm, or you can find me on LinkedIn. Thank you once again.